Welcome to my YouTube channel. My name is Muhammad Ubaid and this is another video of earthquake engineering and software practice. And in the previous video we have discussed how to model the unreinforced brick masonry infill in different types of software and what are the guidelines from different codes. And today we will do the modeling. So what we will learn in this video, how to model the unreinforced brick masonry infill in Etabs. Before we start modeling, we will take some parameters which will help us to model our strut in Etabs. So this is a slide from our previous video, and this slide is from IS 1893 2016 part 1, which we have discussed in our previous video. So we will just start with our example. So we will take a 2D frame for simplicity in analysis and to understand the behavior of strut which we will model. So we will take the concrete strength as FCK is equal to 25 Newton per mm square, and its a modulus of elasticity is 25,000 Newton per mm square, and we will take column size 300 by 300 mm square and beam size 230 by 350 mm square, and we will take the prism strength Fm is equal to 6 Newton per mm square. What is prism strength? Prism strength. Prism strength is determined by doing the prism test on brick masonry wallet. Okay, and this test is given in IS 1905. But if we do not have the result data from test, we can also use this formula to find Fm, because we need Fm to find the elastic modulus of masonry infill. So we will take Fm is equal to 6 Newton per mm square, and we will find out our elasticity modulus of brick masonry infill, which will be equal to 550 times Fm, which will come out to be 3300 Newton per mm square. Okay, we will assume story height 3000 mm, and we will assume bay length is equal to 3000 mm, and from our data we can easily find out the height of infill, which is given by 3000 minus 350. 350 is the column depth. Okay, because we need h infill, this height h infill, so we will deduct the center to center line, which will deduct 350 from center line between the beams. Okay, what is our story height? It is our it is 3000 mm. Okay, this height is 3000 mm, and the depth of column is 350. Depth of column is 300. No, we will take depth of beam in this. Okay, depth of beam is 350, so we will deduct this to get h infill, and the length of infill. In the length of infill we will use the cross section of column. Okay, so the cross section of column is 300 by 300 mm square, so we will deduct it from 3000 to get the length of infill, which is this. Okay, this is the length of infill and this is the height of infill. Now we will assume the thickness of infill as 230 mm, and we can easily find out the moment of inertia of column is equal to bh cube whole power bh cube by 12. So we will use directly the formula for square, which is equal to b whole to the power 4 divided by 12, which will come out to be this value. Now after finding out the parameters, we will just put all these parameters in this formula to find our alpha h. Okay, and now alpha h will come out to be 3.803. Oh, one thing which is important to know is the angle theta. Theta, how can you find theta? Theta can be found easily. We have determined the height h, and we have also determined the length of infill, which come out to be 2700. So we can easily use trigonometry and we can find the angle theta. From this angle we can find out the diagonal length of our strut. Okay, because this length will be used in our formula to find the width of the strut. Okay, which is given by this formula WDS. LDS will be used here, so we have to first find out LDS, and then we will put alpha h and LDS in this formula to find out the strut of our equivalent equivalent strut. Okay, so our width has come out to be 390 mm. So now we have find out all the parameters. Now we will start the modeling in Etabs. So let's get started. Okay, we will start our modeling in Etabs and we will just modify this structure for our model, and because we will take only a 2D frame, so let us first change the story data. Okay, this is our story 4 and we will just delete this story. Okay, let us take 3 story, no problem, and we will just modify our grid data also. Here we have two grids in x direction. We will just delete the grids in y direction. Okay, now it will be only a 2D frame. It is refreshing the window. We can see it also in elevation. Okay, so here it is. It is the elevation, and we can also see it in this window. So here it is. Now we will define our material property. So these are the default material, and we will add new material as we have discussed in the slide. We will use Indian and concrete FCK M25. Okay, this is the chart, or this is the table of properties. We will just okay it, and we will add the rebar material FE415 Indian code from Indian code, and we will also click OK. Now after this we will define the section property, frame section, add new property, rectangular, and we have taken column size as 300 by 300. Okay, so here we will just put 300, and we will also put here 300, and we will change the material to M25. We will not we can also change the reinforcement if you want. Okay, and one more thing, we also have to change the rebar material which we have taken as Fe415. Okay, there are many other properties like the cover. We can also change all these things, but we will not go in detail as our focus is to model the strut. Okay, so now we will define our beam section. Beam section was 230 by 350. 230, sorry, 350 depth and 230 is width. It is our beam M25. Okay, rebar material, it is M3 design for beam. Click OK. Now we have defined our section properties. We can delete these section properties, but we will just left it as it is. Now we will draw the column. First of all, we will draw the column. Three 300 by 300, all stories. like this. Now column has been drawn, and now we will draw beams. All story. Okay. Now we will assign the supports condition. So we will choose the bottom nodes like this, and we will assign joint restraint fixed support all degree of freedom restraint. Apply and okay. Now we have applied the support, and we all have also drawn the beam and column. Now we will define our section property for strut. Now if we use this table, okay, and this rectangular section, we can use the property, okay, for our strut, because we will use the property of masonry. No, we will not use the property of concrete, so we cannot use this section, okay. So we will just use the section designer for this, okay. So first of all we have to define the material property. So add new material. From here we can choose other, or we can use directly masonry, okay. Now it will show the parameters for masonry. Now we can just click ok. Okay, now we have defined the material. We will draw our section. So add new property. We will just use section designer. Now we will name it as strut material masonry, and we will use the section designer for our model. And we will just click here, draw concrete shape, draw rectangular, and we will just click at the center of this axis. And now we can change the property. Like here we can change the material masonry. We can also change the name, and we will just change the width and height of this stud. The width of our stud was taken as 230, which is same as the thickness of our wall. And now we can change the height. The height was found out to be 390 mm. In our slide we have discussed all these things. Okay, okay, and we will click ok here again. Now we have defined our section. Click ok, and the name of section is strut. Okay, now the main thing come, how to draw the strut in our model. So we will in the left corner we have a quick draw braces, okay. We will use this icon. Click it, and a window will open here, small window, and from here we can choose our property. So here it is strut, okay. Now from here it is pinned. We will use pinned because we have discussed that the strut will act as a compression member, which is only which will only take the axial force as the truss, okay. So it should be pinned at both the joints, okay. Now here, from here we can change the type of bracing, okay. So we will use the eccentric back or eccentric forward. How eccentric back will look like? It will look like this, okay. So we will go with this eccentric back, and we can just draw this in all the frame. Now we will, after defining all these things, we will define our load case. Here it is. First of all we will define load panel. Load panel, we will take dead load, live load, and one load pattern which we will take is earthquake load, because we will apply lateral load. So we can use earthquake load to apply lateral loading, or we can use directly any other loading. seismic EQX in X direction. Okay, and IS 1893 we can use also, and we will just go with this, or we can use the latest code IS 1893 2016. Add new load. Okay, modify literal load. We will just use the X direction, and we will just left all this parameter as it is. Okay, okay. After defining load pattern, we will define check our load cases. So here it is. We have our EQX. Okay. Now after running the model, we will check one more thing, which is mass source. Okay, it is okay. Or we can just go with this, change this thing to specified load pattern, add live load 0.25 as specified by our code IS1893. Okay, okay. We will check one more time. Okay, okay. One more thing we will check, which is diaphragm. We have to assign diaphragm because we will apply earthquake loading here. So we have 1, 2, 3 floors. So we will add 3 diaphragm, rigid type. Okay, okay. Now we will just go in elevation. Oh, sorry. We will just go in plan view. We will assign our diaphragm in plan view. For assigning this, we will select our XY plane like this, and we will just assign joints diaphragm D1, apply. Okay, it has been applied. Now we will go to our next story level, which is at 6 meter. Again select coordinate XY plane, again select this. Now assign D2. After this we will change our story level, which is at 3 meter, and again select coordinate XY plane, assign D3. Okay, now we have assigned the diaphragm level also. After all these things, we will just analyze our structure and see what will be the response of our structure. Okay, first of all we will check our structure. So that we may know if there is any mistake in modeling. It is now checking the structure. One more thing which I would like to discuss here, that we are using linear analysis. Okay, because this earthquake analysis which we have defined in our load case is linear case. We are not using any non-linear analysis here. So our model is okay. Now we will set the degree of freedom. So we are using 2D. So we will just select XY plane in which our model has been defined. Okay. Now we will select load cases to run. We will run all the load cases. Run now. Okay, sorry, we have not saved this structure. Okay, so we can save exa, or we can save eq. Okay, now it will run the structure, or it will analyze the structure, and we can see the results. It is analyzing the structure. Here you can see the updates of analysis. Like right now it is checking and updating model. It is creating analysis model right now, and now it is ready for analysis. It takes some time to analyze the structure. Okay, it depends on the speed of the computer and the type of analysis which we are doing dealing with. Now it has analyzed the structure and it is refreshing window. Okay, now we can it is again refreshing the window. Okay, now the analysis is going to complete. So here it is. It is again refreshing the window, and after this analysis will be completed. So the analysis is just going to complete. Okay, the analysis has been complete. Now we can see the forces in our strut from here directly. Axial force apply. Okay, this in this window. We will use this window. So these are the axial forces in our strut. Okay, and in the same way we can also see all other responses like moment. So here is the moment, and in plane moment we can also see this is in plane shear. So in this way we can model our infill wall as a strut member for the analysis, which will make our structure analysis more accurate than the usual practice which we do. So this is it for this video, and if you have any query, any question, any confusion regarding this modeling or how we have done this, please comment down in the comment box and I will try to answer all your comment as soon as possible. And if you like this video, please subscribe to my channel, and if you want more informative content, please comment down in the comment box and share this video. And thank you very much. We will meet in our next video.